When dealing with forces and systems of forces, we very often find we have an object, let's show us a point right now, with various forces in various directions, F sub A, call this one F sub B, and each force may be of a different magnitude and of course pulling or pushing in a different direction. And one of the most important things we need to be able to do with these forces is to arrive at the resultant of all these forces. What will happen to this body under all these different forces? So to arrive at a resultant, we find that there are a couple of ways of doing it. Perhaps the most convenient way is to resolve, I put that word over here, resolve, and we'll explain this in more detail, resolve each force into its components. So let's imagine for just a moment I had a XY coordinate system along here. This is the x-axis, the y-axis. What I would do is I would say, well, this particular force is really made up of two components. One that's pulling along the x-axis, this much, one along the y-axis, this much. So this vector, and the force is a vector, has two components to it. One along this axis, one along this axis. And then I would take this second force, F sub B, and also resolve it into its two components. Let's see if we can picture, here's what one would look like. That's the component pulling to the right, and has a part that's pulling down. And then I would say, all right, now instead of these two forces, let's consider these four forces. 1, 2, 3, 4, and add those together. And since they are collinear and these are at right angles, it's easier to just solve the problem that way. So we would find a resultant in the x direction, we would find a resultant in the y direction, and then put them back together again. And do this by using Pythagoras' theorem, which says I would square both of these, add them, take the square root of the sum of the squares, and this would be the resultant. So that'd be the resultant vector, the resultant force from the original two forces. So we've gone from forces into a coordinate system by resolving them, then bring them back here to give you a resultant. The resultant will also have an angle. Call this angle theta, which could be along with respect to the x-axis, and this angle theta would be given by the angle arctangent, which is given by f sub y over f sub x. So with respect to this axis, I can have a resultant that has an angle theta, and that's the way I would find the value of theta. So what we plan to do is to work several examples along these lines, because this is typical of the type of problem that you will see on the examination. Now, how do you resolve a force into its components? Let's say I had a force. This would be my XY coordinate system. Let's imagine that one of the forces I'm given looks like this. Call this F sub A. F sub A is given to us, and I'd like to find out how much of it is along the x-axis and along the y-axis. If we call this angle alpha for now, then I would find this component along here, call it the F sub A sub x component, is equal to the magnitude of F sub A times the cosine of the angle alpha. And similarly, there's a component along the y-axis. Call this component F sub A, the y component. That'd be the same as F sub A times the sine of alpha. So by simple trigonometry, I can resolve any force into its components. If it's over in this quadrant, nothing else changes. This now becomes the angle alpha. And if this happens to be the force F sub B, then I can say F sub B along the x-axis is equal to F sub A times the cosine of alpha. Now it turns out when you do this and you go into the second quadrant, which is where we are, we'll get a negative result for alpha, because alpha is somewhere between 90 and 180 degrees. And that's exactly what we expect, because F sub B sub x is going this way. And similarly, F sub B sub y would be the same as the original, pardon, this should be f sub b, should be the same as the original f sub b times the sine of alpha. So resolution into components is really quite simple, but it's very important to be able to do this.